Welcome everyone to this webinar. I titled it Future Shock. Future Shock was the name of a book you may recall from the early 80s, I think. Alvin Toffler wrote a book. I don't think he came up with the term future shock, but he used it in his title of his book. It became a bestseller, sold millions of copies, talking about all the technological changes that were going on at the time. And I looked at it yesterday. I looked at kind of a summary of the book and his main points. And it seemed, from today's perspective, seemed rather tame, right? The technological changes that were happening that he was writing about. But in any case, I like the term. Lots of other people have used it, I'm sure. And the focus of this webinar is future shock related to the rise, what I'm calling the rise of the robots. So I know there's there's a tsunami of interest right now in AI. But kind of along with that, we have the rise of these robots, and it's not getting as much attention, I don't think, probably because it's not available to us. These robots are not really available to us, so it's not quite as immediate as AI, where you can go into ChatGPT or Claude and log in and use it. So, but nonetheless, could be as important or maybe more important than AI, or it certainly goes hand in hand with AI. So that's the topic, and it's such a huge topic, the potential impacts on everything, that we could go on for literally days. So I'm narrowing this discussion, or trying to narrow this discussion down to the impact of robots on what my audience typically does, which is the realm of lean manufacturing, continuous improvement, material flow, manufacturing, engineering, those kind of issues typically related to manufacturing, and how these robots might impact us, in what we do and the world in which we typically work. Okay, so here's a picture. It may be difficult to see this on your screen. I'm not sure. It depends. If you're watching this on a phone or something like that, it might be additionally hard. But this is a picture taken in 1900 of Fifth Avenue. And again, it's going to be virtually impossible for you to know this, but basically what you see here are 100% horse-pulled wagons or carriages, with one exception that's circled in red here, which is a car, an automobile, in the year 1900. So, and in fact, at that time, the city fathers in New York were concerned because they said, hey, if the city keeps growing the way that we're growing, then our biggest problem in the future is going to be, how do we get rid of all this horse manure? Because it's going to pile up to the second story of buildings. So that was one of their big concerns. So this is in 1900. Now flash forward to 1915. So remember, this is over 100 years ago, and same street. And what you see here are all automobiles with, again, there's a circle in red, one horse-driven carriage. So that transformation happened in 15 years, or maybe a little bit less. So in case we think that these technological transformations can't happen quickly, a long time ago, they did. I mean, imagine that if that time frame compared to today would be around 2010, right? 2010, let's say. In 2010, we had horses, and in 2014 or 15, today, we have no horses, and we have all cars. I mean, that's an incredible transformation. So what we're talking about here with robots is a similar kind of thing, where today we have virtually none, and within a very short period of time, we could see a massive transformation in terms of the availability, use of these robots in society. And by robot, I'm not just talking about any robot, because we have a lot of manufacturing robots today. But what I'm talking about is what's called a humanoid robot. So what is that? So here's a definition. A humanoid robot is a machine designed to physically resemble and move like a human being. So it's got a head, it's got a torso, it's got 2 arms, 2 legs, along with sensors, and importantly, AI, or artificial intelligence, that enables it to interact with humans and the environment in ways that mimic human capabilities, such as walking, manipulating objects, speaking, and responding to stimuli. Now, why is this important? Well, because at least for the time being, our world, our developed world that we live in is geared or designed for humans, for us. And so if we have a humanoid robot that can emulate those kind of actions and tools, they'll fit right in, right? They'll be able to fit right into our chairs and seats and use our keyboards and our piano keyboards and the cars and tools and everything that we currently use quite seamlessly, assuming they're able to do that. So that's what we're talking about here, the rise of humanoid robots. And here's a quote I came across a few days ago. This is from Dr. Pero Mishik. I'm not sure how to pronounce his last name. I think it's a Serbian last name, but he's in Germany. He's a professor. I kind of like what I saw so far on YouTube. And he's running, in addition to his teaching responsibilities, he has this group called the Future Management Group. And the Future Management Group is a group that he formed or is spearheading to help people like ourselves make this transition, right, to this world of humanoid robots. And what he's calling humanoid robots is the biggest technology innovation. I guess you could say potentially, it hasn't happened yet, but the biggest technology innovation and disruption in human history. Much more than the car, much more than electricity per se, much more than a lot of things. Hugely disruptive. Jonathan, yes, the iPhone was introduced in 2007, so that wasn't that long ago. And now it's just like, who has a landline anymore? I mean, it's pretty much taken over, right? And in relatively short time. So the question is this what's coming? Yes or no? And if we say yes, probably, then how do we prepare for this? And how does this impact our world of lean manufacturing? So what we're looking at, what's coming down the road, is this. Humanoid robots are rapidly approaching a point, and this is from this professor, approaching a point where they will be physically able to manipulate things in the physical world and cognitively with AI, capable of performing most human jobs at a significantly lower cost. This will have the profound implications for the future of work, income, and even the meaning of life. So one of the things in manufacturing is going to be this. If these humanoid robots are capable of doing work that a human could do, and they are significantly cheaper, not a little bit, significantly cheaper, and we'll explore that in a minute, then manufacturing companies are basically going to be forced to convert to humanoid robots, because if they don't, they're not going to be able to compete in the marketplace. If they have humans doing work and a robot is significantly cheaper to do that same work, then they're basically going to be forced to make this change, make this shift in order to stay competitive. So that's what we're looking at. So our key assumptions here in this discussion, in this webinar, are several. Here they are. We're going to assume that humanoid robots will eventually, so I'm not saying tomorrow or even next year, but within a relatively short period of time, eventually we'll be able to perform all human physical activities, all physical activities of humans, all of them, eventually, not right away, right? So there'll be a transition period. Eventually, all of them. That includes playing the violin, typing on a keyboard. I've already seen images of humanoid robots doing that. So a lot of the things that seem very human, like typing out things, they'll be able to do that. Second point, humanoid robots will have an AI brain. So this will make them cognitively intelligent. And if you've been following the progress of AI, you know that it's moving ahead at a breakneck speed. And so at some point, it's actually been said that within a few thousand days, AI will be at the level of artificial general intelligence. That was the head of OpenAI. Within a few thousand days. So that is coming. Third point, humanoid robots will learn new skills at enormous speed. Now think about this. This kind of blew my mind when I started thinking about it a little bit more. The amount of effort and expense and time that are required to bring someone like me or you up to speed as a human being, from a baby, right, all the way up to being able to work and function as an adult. The kind of education and training required is enormous. It's unbelievable. Not only the expense and the effort, but the time. Like, that doesn't happen in a few years. It happens in, 20, 25 years to get someone like fully up to speed as a human? That's incredible. But humanoid robots, the image I'm remembering when I think about this is The Matrix. You've probably all seen the movie The Matrix. And think of this. There's a scene in there you may recall. They're in the Matrix, and it's Neo and it's Trinity, I think her name was, right? Neo and Trinity are inside the Matrix, and they're trying to escape from these agents, and that's another word that like we're using today. And they jump into a helicopter, and Neo says to Trinity, "Do you know how to fly this thing?" And she said, "I will in a minute." And then she communicates to the guys back in the ship, the home base. Load me the instructions for flying this helicopter, and it's done. And now she can fly the helicopter. Well, it's going to be a little bit like that, because once we train one robot to do a particular skill, the effort to train all the other ones would be instantaneous or very easy, because it's really just instructions, right, or code that we're transferring over, just like in the Matrix. So if we have a humanoid robot that's doing housekeeping, once you train one robot how to do something properly, like iron a shirt, that skill can be transferred more or less instantly to all the other humanoid robots working in a home. So that's kind of mind-blowing, the difference in speed. Now, they do have to be trained the first time, but once that's accomplished, it should be pretty easy to, expand that, share that with all the other humanoid robots that are around. That's pretty amazing. The last thing is humanoid robots will work at 10 to 25% of the cost of a human, or less. So where did that number come from? Well, they've done some calculations on, and tried to be very conservative in terms of what are the costs of these robots, including maintenance costs. And remember, a robot doesn't need 8 hours of sleep. They can work much. You can get a lot more labor hours out of a robot. Maybe not 24, but maybe close to it, right? If they can recharge just on a induction kind of recharging situation, and so you're going to get a lot more work out of a robot. And then factoring in all the the energy costs and maintenance costs, et cetera, they're estimating that probably even relatively soon these robots would be about a quarter of the cost of a human. But that's only getting started. There's this concept or law called Wright's law that says that every time you double the production of a product, let's say an automobile, the cost of that will be reduced by some factor. So I think, if I recall correctly, it was maybe cars, where every time you double the volume of a car, that cost will drop by, say, 15% or 20%. So when you get into mass production on these robots, the cost of them is going to drop dramatically. It's just the cost curve, So I've seen some reports that are projecting that humanoid robots will be much less than 25% of the cost of a human, starting with, say, $10 an hour equivalent for a humanoid robot, down to $1 an hour per, for a humanoid robot, down to even less than that, maybe. So who knows? We'll see. But in any case, the projection is way cheaper than humans in terms of just pure cost. And that's why, companies will not be able to not do this, once they become available. Now, this isn't just pie in the sky. These robots are actually being developed. There, I think in the United States, what I recall reading was something like 25 companies are actively involved in creating humanoid-style robots, sometimes with different target markets like manufacturing or multi-purpose, general purpose, domestic use, etc. In this picture, there's one. The second one from the right is the Tesla robot. Not sure about the others, but there are a lot of them that are coming online. And if you're curious and want to explore this, all you have to do is go to YouTube and do a simple search on show me humanoid robots, and you're going to get more information than you can deal with. You spend all day learning about this stuff. So this is very, very active, and not just here in the United States. Here's the other thing that's going on, which is really quite incredible. China, the government of China, has announced that the humanoid robot market is a key target, key goal for the country of China to dominate the robotics market, the humanoid general purpose robotics market. And the plan, just roughly speaking, from what we've learned, is that by next year, so 2025, the goal is to have some of these robots in mass production. So remember, we talked about the cost curve. That will start taking place for some of these robots. They already have some simple ones who are probably not good for much, but they're being sold for something like $16,000, I think, humanoid robots. But you're going to see the cost of these, come down dramatically if they're in mass production. And their goal as a national strategy in China would be to dominate that market, whatever that means. But from a cost perspective, from a capability perspective, dominate that market by 2027. So that is, 3 years from now? So this isn't 2030 or 2040 or 2050. This is a few years from now. China plans to dominate. And they may be able to do it because a big part of the supply chain for building humanoid robots is currently in China. They have something like 4,500 companies in China that are part of the supply chain, building components, building sensors, building actuators, building all the pieces that are required to build these robots. A lot of that today is happening in China, not everything. And I think probably the brain of the robots is, we're still ahead in the United States with that technology, but still they have a leg up, and they do have the support, the funding of the Chinese government to make this happen. So very interesting development. And by the way, this isn't just a commercial concern, because these robots can be used for other things like military purposes, for example. There's some pretty scary videos on YouTube about bots or humanoid robots used as warriors, as soldiers. So all kinds of implications, right? If we get behind the United States, I'm talking about. Okay, so let's shift focus a little bit and get into our target area. Now, where did this information come from? Well, I've gotten in the habit of asking my good friend Claude AI or ChatGPT for input on some of these subjects, and usually I'm quite satisfied and amazed usually about what I get from them, from those two. Especially lately, I've been using Claude AI as my primary chatbot, AI friend, consultant. So what I did was I did a series of interviews really with Claude about the subject, and I'm going to share that with you if you have the patience to do it, to read it. But here it is. I'm activating it here. It's called Robot Topics with Claude, and there are a few other things in there in this document. It's a PDF, but it's over, I think it's 60 pages. So there's just a ton of content, much more than I could ever include in this webinar, unless you wanted to be here all day. But if you want to read through it, I think you'll be amazed and interested in this conversation. So feel free to download right now this robot topics, where I go through quite a long discussion. And a lot of Claude's responses are very bulletized. So we could have expanded on a lot of these topics that he brings up, or she brings up, or it brings up, and have like 500 pages easily, probably, of discussion and content. So quite amazing. So welcome to it, and hope you enjoy that if you have the time to go through it. Right. So let's go through these eight ways that humanoid robots will or could impact our world of lean manufacturing, right, one by one. So the first one is assembly line operation. So this is pretty obvious, I think, expected. So what we're talking about here is robots that are able to replace human assemblers or human workers in a factory, doing assembly of components, also as a part of that same process, doing quality checks or inspections. So the idea of having an external quality inspector is really not necessary anymore. The AI could be doing work, and if there's something, workmanship quality seems to be pretty much a given, unless the robot malfunctions in some way. But there are other quality concerns that maybe are outside of the workmanship area, but those could be built into the work that's being done, as the work is being done. Bringing quality to the source is kind of the expressions that's used, to the point where the work is actually being done. That can be done. Now, third point here on third bullet is flexible adaptation to different product variants. So this is kind of our wheelhouse at Leonardo Group, my company, mixed model manufacturing. So in theory, these bots could be trained in every different model coming down the same assembly line, so that the transition from one model, one product type, one product variant to another would be zero. And they could handle a lot of variation on the same assembly line without missing a beat. Now, there is going to be probably a transition period as these robots introduced, where they'll be working alongside humans, right? They'll be collaborating. So it'll be a co-pilot, right? Co-robot that's going to be working with humans. It would be extremely unlikely and hard to imagine that robots would replace everyone immediately. So you're going to see robots coming in, and that's happening today. I know BMW is introducing them. Tesla is designing robots primarily with a function to help out in the factory. So that's already underway. So that's something we can certainly expect sooner than later. Ultimate and flexing. So if every robot knows every product going across a particular station, then that robot could also know every station. So every station times every product going down that line. So this is the ultimate in what we call flexing, or the ability to move to the work. Right now, humans' ability to do that is based on their level of certification or their level of training. Can a human move to any place in the assembly line and do quality work? Probably not, right, today. If they're trained and certified to do that work, yes. But in a robotic world where we already talked about how training can be transferred electronically over Wi-Fi or Bluetooth, then that no longer becomes a limitation. So we could envision a factory where you could regulate the output of that factory in terms of volume simply by removing and adding robots and not changing anything else in the factory. So it could go from 0 or 1 unit all the way up to the maximum capacity of the factory, which is much greater than what it used to be. Because if a factory is only working one shift, remember, you've got 2 other shifts or 16 hours where the factory is idle. But the robot is not limited. You don't have to hire new robots to cover those other shifts like you would with humans. So the robots can work continuously through and actually consume what is now wasted capacity. So take advantage of additional capacity and take advantage of regulating the volume of that factory simply by adding and removing 100% cross-trained robots. So it's kind of mind-blowing, I think. Final point, workmanship errors are pretty much non-existent. Of course, a robot could malfunction. I mean, that's something that needs to be considered, taken into consideration. But basically, other than that, they don't make mistakes. They don't lose focus, get distracted, pick up the wrong part, etc. They're 100% focused, and they're doing 100% standard work as they've been trained. So that's a change. Next major task for robots is, again, this is not a surprise, right? Kind of expected, is that they would do material handling and logistics. Now, this is already happening today, right, to a certain extent. Certainly, Amazon has robotic type help in the factories, but if we have a multi-purpose, general purpose humanoid robot, then they can be trained to do anything that a human does today, including driving the fork trucks and moving things around, doing physical inventories. So a lot of the basic functions of material handling, raw material, transportation to workstations, warehouse management, so picking, packing, loading, unloading trucks, opening containers and putting parts away. Now, this is an important one, kitting operations for assembly lines. Now, one thing that is clear, and I just know, I'm sure many people are doing this, but I've just seen it in action at Toyota, is that if you can efficiently create a kit and present that to an operator, a kit meaning a set of parts, as opposed to a Kanban situation where you've got bins in front of the operator and the operator picks the parts that are required. If you can give them a set of parts, then probably your error rate in terms of part selection is going to be lower because you're giving them the parts that they need, the right ones, if it was kitted correctly. And you're reducing the time required to select parts, which is could be a small percentage of the cycle time, or it could be a really big percentage of the total cycle time or takt time. Just to retrieve the parts. So if you give the parts directly to the operator, this is like a surgeon. It's like asking a surgeon to go find their own tools or instruments, or giving it to them, putting it right in their hand. So kitting is a move in that direction, giving them exactly what they need. So if we can do that efficiently, then that's a direction that I think would be beneficial for just about everyone. Remove all the material from the assembly line other than what they need to do the work and build that unit, and nothing more. Now, the reason we don't do that today is kitting is extra time. There's kind of a bias against kitting because they think it's a lot of non-value added work, the logistics of kits, et cetera, et cetera. So, but with robotic labor that's more accurate and a lot cheaper than humans, we can move in that direction. So that's kind of my feeling about that. The robots could conduct physical inventories and maintain high IRA. That's inventory record accuracy. Inventory record accuracy is critically important because if you don't know what you have, then you can't really plan, right? You can't really communicate accurately with suppliers, et cetera. So maintaining a high, by high, I mean like ideally 100%, but let's say 99% inventory accuracy is an important aspect. It's important today. It's just that it's harder today to achieve that if you have human beings that are doing things that are not standard work, or get distracted or get tired and don't execute the way we'd like them to. Final comment here. Final two comments. So just-in-time material delivery related to kitting means that it would become cost effective to deliver kits, right, to the workstations where assembly is taking place, whether humans are doing the work or whether robots are doing the work. It doesn't make any difference. You still want to apply that strategy. The other thing is AI managed plan for every part. So this is more an AI kind of issue, but I could easily see in the future AI managing the supply chain, completely. Mark, I'm just looking at chat here for a second. Mark, you're raising a great point, not just for China, for aging population, but many countries have aging populations. In fact, many countries have population decline at this point. Italy is in population decline. Japan is in population decline. Italy has something like many countries have thousands of houses that have been abandoned because they're not needed, and or people are tending to want to live in cities as opposed to out in the countryside. So there are like thousands. I saw a YouTube video of a couple that bought a really beautiful house in Scotland that had been abandoned. And the government doesn't want these houses abandoned. They want people living in them. So they were able to get it for next to nothing and remodeled, refurbished it. But China has the biggest problem because they had the one-child policy for so long. The forecast in China is that the population is going to be declining from today, which is something like 1.4 billion, right? Within the next 50 years, decline by hundreds of millions of people, fewer people in China, because that population curve, which is normally kind of a pyramid with younger people kind of at the bottom, it's like inversed. So you have older people at the top of the pyramid and fewer younger people, coming up through the age ranks. And China has that as a serious problem. Okay, Jack will talk about maintenance here in just a minute. That's one of our challenges. Next one, maintenance. Funny you should mention it, Jack. So maintenance and equipment care. So maintenance of machinery, assuming we're still using that, we still have manufacturing equipment. So routine inspections, checks, and adjustments. Remember, we're talking about a humanoid robot that physically can do anything that a human can do and is smart or smarter than human. So certainly they can do routine equipment maintenance checks and do adjustments, et cetera. Routine maintenance, that should be kind of a no-brainer. And probably even basic repairs and part replacements. That's probably a no-brainer also. But more complex maintenance, probably for some extended time, humans would need to be involved with that. But eventually, why couldn't a AI general intelligence humanoid robot do that as well? No reason why they couldn't. Basic cleaning, sanitization, those kind of activities could be done robotically, no problem. Managing tool cribs, organizing tools, maintaining tools, sharpening, all those things that need to happen certainly can be done. And then there's this other interesting thing regarding maintenance. You've probably, if you've been interested in the subject, heard that machine learning has allowed, there are systems that allow the use of machine learning to monitor equipment for vibration, and have sensors, right, that do this, that monitor vibration, even the sound, the pitch of the machine operating. And through machine learning can detect when something changes. So that change may be tool wear, right? The tool is starting to wear out. The sound is different. We learned that through machine learning by analyzing a ton of data. And therefore some maintenance action may be called for. Or it could be another subtle, maybe it means that a bearing is starting to go out, for example. And we're detecting this way ahead of time. So we're not waiting for that bearing to fail. We're detecting these changes, and then we can do, predictive maintenance, basically. I think that's the term they use. So we're predicting the changes. And certainly robots that are smart enough and have these sensors kind of built in could be performing those kind of changes without maybe even needing extra, other sensors. They have the sensors built in and can do that. Who knows? So we have, good opportunities there. Quality control. So a lot of quality issues, especially workmanship issues, should be going away because the robots are doing standard work, and that work has been vetted, and they're doing it the right way, and they can actually be checking their own work at the same time. So a lot of quality issues we have today, but not everything is going to go away. So we could be building into the humanoid robots, because they have cameras, the ability to do inspection of their own work, certainly, and we may even allow them or give them the capability of doing physical testing if that's required, as the work is being done, because clearly the point at which the defect could occur is the point where you want to do the test. and not let it go down the line. So that kind of thing could be built into the quote unquote standard work that a robot is doing. Defect detection, sorting, real-time quality data collection could be happening at the same time. Check-to-check is a term that we use to try to improve workmanship quality. The idea here is that when you do work and there's a possibility of doing it wrong, in other words, the work itself is not error-proofed. You can do it wrong. If you got distracted, you're tired, you could do that work step wrong, then it's not enough to just do the work and move it down to the next station. You've got to, at least at a minimum, check your own work. But checking your own work, if you're a human, is not the best solution because you did it, and so there's going to be a tendency to assume that you did it right. So what's better is to have a fresh set of eyes. So the check-to-check is you check the work coming to you from an upstream station, let's say in an assembly line environment. So it's coming to you. You do a check before you do any of the work defined for your station. You do a quick check to make sure that you're not receiving any bad material, right? That the work was done properly at the previous station. Only for those steps that could be done wrong. Okay? And then you do your work, and then you double check your own work, and so on and so forth. But that methodology should be unnecessary in a humanoid robot environment because they've been trained to do standard work correctly. They don't get distracted. They don't get tired. And you could build in some self-checks if necessary. But that whole issue should kind of go away, I would think. But if we do have to have additional tests or things that are not detectable, then that could be built into the work as well and not allow things to get, to get down the line and further value added. Next thing, value stream support activities. Okay, what could humanoid robots do for us here? Well, 5S implementation, monitoring, maintaining 5S, certainly. That's kind of, the factory equivalent of housekeepers for us in a home. So that's something. Visual management board updates. So if we have a combination of humans and humanoid robots, that's something, a service that they could provide, maintaining our management boards, maintaining KPIs, for example, keeping track of that, keeping track of progress charts, etc. If we have safety concerns that need to be monitored and identified, that's a function that a humanoid robot could provide. Remember, back to your question, Jonathan, under what circumstances do we need humanoid robots? Well, we may not, quote unquote, need them, but if they're 1/10 the cost, then companies are going to be forced to use them, as opposed to paying someone to do something that you could have a robot do for 1/10 of the cost. That's a big part of it. But in general, and we'll talk about the differences between humans and humanoid robots, they're probably going to do those tasks better. So not just cheaper, but better than humans could do it. Work standardization documentation. So documentation, I'm saying in the future, if the documentation is for robotic use, for humanoid robot use, that documentation could be, instead of text-based, it could be code-based, and and easily transferable from one humanoid robot to another or to the whole team. So lots of good help that we can get there. Now, here's something that's going to start digging into tasks that people think maybe are robot safe, and those are skilled manufacturing tasks. And probably for the time being, that's going to be true. Right? There are certain tasks that robots today simply cannot do. Right? Humans have to do them. So we have tasks like welding and joining operations. That's a nice image. By the way, I hope you're enjoying these images. They're all generated by ChatGPT, DALL-E. Welding and joining, finishing, painting, complex assembly that require a lot of dexterity or fine motor skill, monitoring and operating machinery, complex machinery. So basically, these are tasks that require a lot of training and a lot of practice to really get good at it. And one of the big differences is once you've trained a robot, like we've said multiple times already, train them how to do that correctly, then that skill can be deployed, right, across to other robots, basically in 0 time. So we have those kind of tasks that, at least in the longer term, should be able to be done by humanoid robots. Why not? And then the last thing is we also have tasks, especially in industries like aerospace and others, that require outside processing because they're too complex or dangerous or various reasons. We don't have the skills, right? We don't have the internal capabilities to do these tasks, so we have to send it out, and then it has to come back. And all that adds a lot of cost and delay. I'm speaking from experience. I spent part of my career in the aerospace industry, aerospace and defense, and so we have a lot of processes like that, where you send out to a specialist of some kind outside. But if these human robots can be trained to do these specialized tasks, I see the opportunity to bring a lot of processes in-house, be more vertically integrated in a lot of the processes that today we might have to outsource, but today we can bring them insource those kind of tasks. Okay. And John says, why humanoid? Because most of the tools, equipment, vehicles, machines, everything that we use in the world today is designed for humans. So humanoid robots will be able to fit right in, right? Use the same tools that we're using, operate the same machinery, drive the same cars. Longer term, there's no reason why they have to be humanoid, but there's a big advantage if we can get these smart humanoid robots doing that. Working with the stuff that we already have. Training and documentation. So if you're a lean specialist, this is a big part of what you presumably do. So you're working with teams of people, training, coaching, and certainly AI robots, if they're needed to do that, can start taking over some of those jobs. So demonstration of standard work procedures, creating work instructions for humans. The AI can already do a big part of that. There's a company I should mention, by the way, called Retrocausal. And they have available some products. One is called Assembly Copilot. The other is called Kaizen Copilot that does some of these things. In other words, it's not a humanoid robot, but it'll observe work and document that work and get trained in doing that work, and then be able to coach and train human beings to do that work and actually monitor their work, so that if someone does something out of step, out of sequence, or selects the wrong part, they'll get an alert saying, hey, you picked the wrong part, or you're doing something out of sequence, those kind of things. So these tools, it's quite remarkable. So I invite you to check it out. Retrocausal.ai, go to their website and see what they have to offer. It's pretty amazing. So a lot of the stuff is already happening, but not in the form of a humanoid robot. But robots could also be doing things like Gemba walks in terms of training and documentation, do things like Gemba walks, do things like value stream mapping. If they're as intelligent or more intelligent as a human, and they have vision capabilities and ability to walk around, they should be able to do a lot of this work themselves without requiring humans. So create value stream maps, etc. And then, of course, the training that they do could be much more effective than current training. With current training, typically you have a room full of people and you have a presentation kind of like this one, and you're trying to train them. But from an AI or from a robotic point of view, that robot could be used to train individual people at their own pace, at their own level of understanding. And that's a benefit not just for manufacturing, clearly, but for education in general. The people learn at different speeds. They learn with different modalities. Some people are very visually oriented. Some people like to hear. A lot of people have to do, right, to really understand. And a robotic / AI kind of trainer can be infinitely focused on an individual person, right, and do a much better job of training them. All right. Environmental management, I think we're coming close to the end here. So what we're talking about here is, we have a concern with waste in general, but waste also impacts environmental concerns, pollution controls, decarbonization of industry in general is a goal for us. Saving energy, lots of opportunities to have kind of like focused humanoid robots working on those kind of issues, coming up with ways to reduce energy usage, and do things more efficiently, more environmentally friendly, let's say. So that's it. Any other comments here? Why does control have an extra C on quality? Maybe it's a typo, Tom. I don't know. I'm not sure what you mean by that, Tom. Maybe it's a typo. So one thing you can do if you want to kind of assess the potential future impact, just out of curiosity, of robots on your work or your company or your area, is just do a simple matrix and list some of the processes that are done physically, right, by human beings. If it's non-physical, then AI is going to be able to come in much sooner than a humanoid robot and take over some of those jobs. So basically, any work you can do sitting at a computer, typing, or interacting on the internet, etc., that kind of work is really at risk. If not now, then very soon. But physical processes that require agency, that's where physical things are being moved around. Do a simple list of those, and then you can kind of, based on what you heard today and based on maybe some research you do on the internet, on YouTube, is kind of my source of learning about some of this stuff. You could project out that maybe today it's zero or very limited opportunity for automation with robots. But if we go out, boy, this is pretty far out in the future. This is farther out than what I'm seeing. But let's say in a few years, and then maybe 2030 or maybe even beyond, so 2035, get some feel for the change that probably is going to be happening, unless something else goes on. Like, what's going to stop this robotic revolution from happening? Well, not much is the answer. Is not much, unless we have a third world war or we have a massive economic collapse or something like that, or a huge environmental, climate change catastrophe that just, destroys our economies. Other than that, there's not much that's going to stop this from moving ahead. Like I already told you, the whole government of China is behind this 100%. They want to dominate the world with this. So this is something that's going to happen. If you want to get some idea of what to expect, you could do this little thought exercise that you just saw. So where are we today? We're coming to the end here. So where are we today? Well, today, actually, AI and this potential robot revolution is actually, for us as lean specialists, lean manufacturing specialists, or continuous improvement specialists, or manufacturing engineers, it's actually creating more work for us, because AI by itself is really good at coming up with improvement ideas and things to do that just go into our in basket, things that we could be working on. That universe of things we could be working on is just growing. It's getting bigger. So you might even feel like you're not getting any help from AI. What you're getting is just more things to do. Because remember, today, AI doesn't have any agency, right? It can't actually do anything physically, or not very much. So that's how we might feel today, that we've got actually more stuff on our plate than we did before. Now, interim, transitional impact that's going to happen soon. In fact, it's happening now, but it's going to be more and more common, accelerating over the next few years, let's say, is working in partnership, let's say, with robots. In other words, if you're working in a factory, there are going to be certain tasks that are clearly low-hanging fruit, that should be automated, that could be automated. And if a humanoid or other kind of robot, like a AGV, automated guided vehicle, those kind of automations can help, then you can do those right away. So I would envision over some period of years, what you're going to see more and more as the cost of these robots come down, as their capabilities go up, right? Those two things, they'll be passing in the night. The cost is going to be dropping like a rock, and the capabilities are going to be rising like a rocket ship, then you're going to see more and more of these taking over certain tasks. So there are going to be still a lot of people around, but also there are going to be these robots working with us or working on their own. Hot off the press, this morning, as I was just kind of browsing around, there was an announcement from Boston Dynamics, which is an American robotics company, who have announced, I think it's called Atlas. It's the name of their robot. And Atlas was announced as a fully independent robot with a target market of factories, manufacturing environment that can work totally autonomously, right, without requiring too much guidance, right? Can be trained in a job and it'll do the job. And there's a little YouTube video on that announcement. So that was like today. So this is already happening. But again, what's going to be the tipping point, I think, for a lot of these is, number one, the capability. Yeah, retrocausal, there we go. It's going to be the capability of the robots, going up, and it's going to be the cost going down. So there's going to be some tipping point that's going to happen at some point where more and more organizations are going to say, hey, we need to do this. But again, it's not going to be mass transformation. It's going to be in select areas. So be ready for that. Now, here's our vision of the longer term future, maybe that you have, which is, dun the robots are going to do everything, right? And we're going to sit back and drink our pina coladas and not have to do too much. Well, this I don't think will ever happen. Sorry to tell you that every time you introduce something new, it also creates its own problems. So there are going to be plenty of problems, I'm confident, for us to be working on in the future. So don't look forward to this as the future, but it is going to be pretty disruptive, I would say. It's an easy, safe statement to say. This is going to be pretty highly disruptive to the way we're doing things today. So I went back to our friend Claude. Claude is a better friend to me these days than ChatGPT. And I said, well, what are we going to be doing? Let's assume that we're in a post-robotic world where most of the tasks are done by these humanoid robots in a factory, I'm talking about. And give me some idea of what the job description would be for humans in that environment. So Claude came up with this list. You can take a look at it. So robot system architect. Okay, robot human interface. Well, that could be important. Process failure analyst. There could be failures or system failures that a robot can't handle, right? You still need human experts in there. So you can go through the list. Some innovation and continuous improvement specialist. That sounds pretty familiar to us. That sounds like something we do today. So maybe that's something that survives. But in general, I ask myself, and I'll ask you the question: does this sound anything like you do today? Well, not so much, right? I mean, it sounds like a new career based on what Claude is telling us. So are these skills that seem to be required in this new world something that you already have, right? Have you been trained in this, educated in this? Is this your experience? Probably not so much, right? I would say, at least for me. Are you excited about the opportunities to have a whole new career? Well, yeah, a lot of us would be excited about this. Some of us maybe not so much. But in any case, it seems like it's a pretty significant shift from what we do today. Remember, I'm talking about somewhere down the road, maybe a decade or more. So don't worry about this happening tomorrow. But then I said to Claude, wait a minute here, Claude. Here's what I actually said. This was my prompt. I said, since in the future, AI-powered humanoid robots will theoretically have achieved AGI, that's artificial general intelligence, or better, smarter than that, why wouldn't these tasks that you just listed, the 10 tasks I just shared with you, also be performed by AI robots? And so Claude came back and said, you're absolutely right. In a scenario where AGI or ASI, artificial superintelligence, exists and is embodied in humanoid robots, so it exists and humanoid robots actually can take advantage of that, there would be theoretically no, here's a statement for you, sit down, there would be no cognitive or physical task that humans could do better. The robots would have superior analytical capabilities, never fatigue or lose focus, process information faster, access and perfectly recall vast databases of knowledge, learn and adapt more quickly, we've talked about that, make more objective decisions, communicate and coordinate perfectly with other AI systems, and have no physical limitations compared to humans. So that's pretty stark, right? That's a whole brave new world. So can't tell you what to expect exactly. But my final question to Claude was, okay, so what's your suggestion? What's your recommendation to humans? I notice we're getting close to the end here, but we'll make it. So my Claude AI's final recommendation was your value. So talking to you folks, talking to us, or talking to me, your value will shift from managing processes to architecting or designing transformative solutions that blend human wisdom or human capabilities with robotic capabilities. So suggestion is start thinking about this now, start now, think big. Let's assume that this is going to happen, right? Unless something really bad and dramatic happens. This is going to happen eventually, and take it step by step, right? We don't have to jump to the final solution. Just start moving in that direction of assuming this is going to happen and what can we do right now. So I have 4 suggestions for you. This didn't come from Claude, it came from me. So number 1, start using, if you're not already, and probably many of you are, start using AI or large language models, ChatGPT, Claude. There are a lot of other choices, right? Everyone's got their models. Google has their model. Meta has their models. They're all probably amazing compared to a few years ago. The best one right now, I don't know how they have ways of ranking them, but the best one maybe is Claude. It seems to be doing pretty well. So use these models for improvement projects. In other words, find pain points in your organization where some automation could help. It could be as simple as a macro for a Microsoft Excel spreadsheet, right? Automate something you do manually in Excel. And the other recommendation from people that work with AI is be polite. So the AI may be your overlord here in the future, so be polite and respectful in your communication and interaction with AI. But start using it if you're not already, because it's already available right now for some pretty incredible things. Like it's able to write code, write macros no problem, provide some actually pretty good recommendations on a lot of different things, deal with text, documenting. Just don't trust it 100%. Right? It can make mistakes. Next recommendation, develop a strategic mindset and envision future state processes. In other words, assume that this robotic humanoid revolution is going to happen at some point, and start looking around for how this might impact your organization and where strategically it would make sense to start incorporating these. Because remember, once the cost reaches a certain point, and once the capability reaches a certain point, it's not going to be optional for your company not to do it, not to use these robots. You're not going to compete, because if you have competition, your competition is going to be cheaper, faster, better, right? So you're going to have to do it. So start looking around, develop a strategic or long-term mindset for how this is going to roll out. Third opportunity, train your own private LLM. So this is something we're doing. That is, use an existing model. There are open source models available that are really good, and then train those models in your own content, your own IP, right? Your own processes, your own standard operating procedures. So that you have an IT AI helper that's trained in your own processes. Yeah. Pretty easy to do. And that's something, I know some companies are pursuing this partly out of concern with security. Like they don't want to be doing, they're working the military industrial realm, and they don't want to share information. So you can run these large language models locally, not connected to the internet. So that's an option. But if that's less of a concern, there are other things you can do. And then the last self-serving comment I wanted to make is mixed model manufacturing, whether it's robots doing the work or humans doing the work, is kind of the best way that we've come up with on the planet Earth right now to actually build products. And so as a lean specialist, this is something you should probably be familiar with as part of your toolkit. How do you design an assembly line? How do you design a value stream? You don't want to take the value stream mapping approach of looking for opportunities to do things better and then, having a series of Kaizen events. That will, that kind of sort of will move you in the direction of doing things better. That's not what you want to do. You want to apply a step-by-step methodology, and we call that mixed model manufacturing. I say self-serving because that's what we teach, that's what we do. So in order to learn more, if you're interested about that, you need to learn about it. And we have two opportunities there. One is that we teach workshops 4 times a year at Toyota Material Handling in Indiana, because this is kind of how Toyota does it.